This video, we're going to cover switching and the VLAN fundamentals um, for the router on the stick. The topology um, is listed as topic 7, router on a stick lab exercise. Uh, the packet tracer file, and also the key is right underneath it. The packet tracer file, once you download it and open up, you'll be like this. Um, and this is the documentation. The objective of these lab activities are um, from the student virtual image here. This is the student virtual image, and we want to be able to ping the 10 here on the default gateways, which is the Cisco ASA's firewalls inside interface connected. Um, and we are going to use the router on a stick. The packet traveling path will be when the 192.168.11.11 want to ping the 10.10.10.10, it's not on the same network. Its default gateway has been set to 192.168.11.1 in here. So what it will do is, this is VLAN 1 and VLAN 11. VLAN 1 address is 10.10.10.1, which is the 10.10.10 network. Again, be aware that VLAN is a layer 2 technology. So it's a virtual LAN. We set it up as a virtual LAN here, and it's our job to make sure that we make the same IP network, which is 10.10.10, to associate it with VLAN 1. So this router, this is a student router. We set up 10.10.10 network with the host number 1 um, to connect VLAN 1 to the default gateway here on ASA. And the 192.168.11.1, which is assigned to the VLAN 11's IP address. And so you can see 192.168.11 has been also used as a layer 3 network address for the VLAN 11. Therefore, the packet will travel from 192.168.11 VLAN 1 coming here to the switch, and the switch is going to forward it through the trunk port to the default gateway here to the 192.168.11.1, and the router is going to say, hey, I'm going to forward it to 10.10.10.10. Do I know that? Yes, because I'm connected to it. It's in the same physical wire, but logically it's different network. So it's going to carrying the different VLAN flag and going into VLAN 1 here and forward it out. This switch is just a transparent switch, and it's going to just forward it out to 10.10.10.10. And we are going to use PET for this exercise. So therefore, the 192.168.11.11 will go out and using 10.10.10.1's address. So therefore, we don't need to add any routes for it to come back. The next exercise that we're going to do is take that we take the router on a stick up and use the inter-VLAN routing. So all the routing is inside here. And we can have, later on we'll show you, and this switch, it could be a core switch with distribution switch, with the access switch. It could be a whole enterprise network. And so among all those VLANs, could be hundreds of them, we don't need to add any static route. They will already know how to route in between them. And in here, when among all those 100 different VLANs, it's going out to the internet here. When it's coming back, if we don't do the net, then this router will need to know how to send it to different VLAN. But luckily, it's only one connection at a time. We will use like 10.10.10.1 for this switch as a VLAN routing. So then all this Cisco router firewall, it only needs to aggregate the routes. That's what we have learned on the route aggregation supernetting. and tell them that, hey, order 192.168.0.0/16, send it to 10.10.10.1. So one line does all the static routing and make it very efficient for that. Okay, so this is a side note. Just want to bring your attention up, and then later on in the next video, we're going to cover that concept in detail when we talk about inter-VLAN routing. So now we are going to set up this topology, and I already did create a topology for you. You can, of course, create the topology from ground up by yourself. And I also put the student virtual image IP addresses in there because this is pretty much just repetitive that we have been doing it so many times. So I'll just go ahead and put it in and save it as your topology file. And we are going to, of course, if you want to key it in, it will be 191.68.11.11, southern mass, things like that. Default gateway, make sure you set it to 11.1, which is here. And once you set it up, then you're going to power on the 3650. In this exercise, we use 3650 to show you the trunking command. The next exercise on VLAN routing, instead of 3650, I'm going to use a 3560 to show you different syntax. So on config T, we already know what that is. VTP mode, VLAN trunking protocol mode, we set it to the server. It has a server client transparent, and we make it the domain called VTP. You can call it any name you want, set a password, and then we can create a VLAN 11 first. Once we create that, then we will go into the GI 101 and tell them that it's, hey, VLAN 1. Because it's one first port in matching VLAN 1, it's easier. And I choose VLAN 11, therefore port 11, let's make it 11. Then number 2 is a trunk port. It will allow VLAN all the VLAN. And in here, basically it will allow VLAN 1 and VLAN 11. And by default, VLAN 1 will be the native VLAN for this trunk ports. So if you want to configure it yourself, you have to watch out that this cable has to connect to its Ethernet port and goes to the port 11 in here. And then this one will go to the port number 2. Of course, you have to use the 000 router ports. And in here, we'll just use port number 1 to connect it to port number 1 here. Then any port here can connect it to the ASA 5505. So that's if you want to recreate it yourself. According to, of course, the configurations, because we configure the port. We configure port 1 for VLAN 1, port 11 for VLAN 11, and port 2 for trunking. That's why we need to connect it that way. All right. Now, on 4331 student router here, we are going to say, hey, config T, and I don't want you to, if I type something wrong, don't try to resolve the name, so no IP domain lookup. You don't have to do that, of course. Interface GI000, because we connect the port 0, no IP address, because reason is, depends on operating system, but the latest one, the newer one, it will ask you not to give IP address if it's going to be a trunk port. And so that GI000, no IP, and then you will say, hey, GI00/0.1, that's in VLAN 1, that's your native. And then GI000.11, that's a VLAN 11. And you give it an IP address, of course, accordingly. So the single interface here, you will have 2 virtual LAN, and each one has a specific IP address. VLAN 1, we call it 10.10.10.1. And VLAN 11, we give it an IP address 191.68.11.1. Later on, we will use the same IP address, and instead of putting in a router, we put it into the switch, and then make the switch do the routing for us. That's inter-VLAN routing. Okay. Then this is the new concept we just introduced. That you don't have to understand it right now because we're going to talk about ACL later on. So this is just a preview. Since there's only 2 lines, what it means is that it's an IPv4, and we want to do a network address translation. The inside, I'm creating a list 7, access list 7, and associated with interface GI000.1 overload, meaning that it's from the VLAN1 that we want to borrow the address, okay? Uh, which is borrowing the actually 10.10.10.1, whatever traffic coming from access list 7, which is from 192.168.11 network. And the inverse mask, we will talk about that later in a couple of weeks, okay? And of course, this is the default gateway. So don't worry about these two syntax yet, because we are going to cover that. But what it does is, whatever the IP address coming from 192.168.11 network, we are going to borrow overload, meaning using PAT address of 0.1, VLAN1 IP address, which is 10.10.10.1. Okay, that's all you need to know for now for this particular access list and the VLAN mask, inverse mask. Now, ASA configuration, again, it will be covered in detail in the CISS 25. It's config key to go into config mode, and we are going to take the auto config out. So we just copy and paste all this in. By default, it's a DHCP server, and we're going to negate it. Now we're going to tell them, hey, interface VLAN1 IP address is 10.10.10.10, and no shot to bring it up. And VLAN2, you don't have to set it up. So you can say, hey, IP address DHCP is waiting for it. So what it does is VLAN1 is the inside, and VLAN2 is the outside, waiting for the ISP to give us an IP address. That's what usually been set up that way, right? And later on, we will have more setup on the inter-VLAN routings for you to get a better concept of this ASA configuration. After we have done that, then we are going to test the ping from the student virtual image. It should be working fine after we configure those routers, ASA, router, and the switch. So that's what we are going to do. And after we do that, we are going to ping it. And if the link connected to the switch is not on, then we have to drag the power to power it on. And we will later on insert a sniffer between the student switch and the CNASM switch, and to see the ICMP packet and see, hey, is it the translated address or is it the original address being shown up? So just to show, just to utilize the sniffer again. All right, so this is the quick preview of what we're going to do. So I'm going to put this document on the side and started to configure that. We're going to drag this power to make it on, power it on, and power on this one. So make sure the two switches are on. And then we first take a look at his IP address, and you look at the configuration, and you can see that it's already been typed in for you. And then the Ethernet is 11.11. So make sure that those two are already been done for you correctly. All right, now it's starting to turn green, and we'll just wait a little bit for it to come up. And now we are going to configure the switch. So look at the CLI. Now we hit enter a few times. And again, this $1 million question, we're going to say no, right? So then we can configure it ourselves. So then we are going to go into the 3560 student router switch. So I'm going to just copy a few lines together and paste in, and make sure there is no error. Okay. And now we are going to copy those two VLANs, which usually have no issues. And paste it in. And as you can see, we say switch port none, meaning non-negotiated. Okay. Remember we talk about VLAN hopping, the switch spoofing, and also double tagging. Those are the two VLAN vulnerabilities being exploited in some situation, but it can be mitigated with the switch port non-negotiated. So it's fixed. Once it's configured like this, you don't negotiate it into a trunk port. And another, of course, the quick way of doing it is making your VLAN always tag, or make a VLAN into a 999 VLAN that you never use, so it's out of the way to avoid being attacked. So that's just a good practice for that. So now we are going to look at this trunk port now. Copy, and we paste it in. All right. So make sure there's no error. Switch port trunk, encapsulation .1Q, no issue. Okay, good. So what this one says that this is a trunk, and the encapsulation is the .1Q, which is the standard protocol for the trunking, and mode is trunking, and again non-negotiate. And I allow VLAN all of them, or you can say allow VLAN 1, 11, okay, to make it more specific. But be aware, if you created VLAN 12, then it's not going to be able to pass through this trunk port at all. All right, so this switch port, once it's up, then we are going to configure the router. So the router, we already went through the syntax in here. And again, encapsulation .1Q, make it native, and then we give it the IP address and make it a network address translation outside interface. And then 11, let's make it a network address translation inside. No shot, exit. Good. So this is pretty much what we already familiar with. So we are going to go to the CLI here, enter a few times, enable, and then we just go ahead and paste it in. And make sure you roll up to take a look at it. There's no errors. Okay. Usually I only copy a few lines. I will not copy too many lines together, but because I already test this out, so that's why I choose quite a few lines at one time. And we just paste it in again. All right, so now we make it packed. So whenever you want to go out, the 11.11, the default gateway is 11.1. It's going to send it to here, follow this line, 1/6 physical cable coming in here from the same cable going out, all right? And then go to the destination. That's a router on a stick. Now we need to configure the ASA. So we're going to config T, and let's take care of this one. Copy. Enable. No password. Show run. Oh. Take a look at it. 192.168.1.1. Well, it's probably have some of the older exercise in there. So I'm going to write erase it. Okay. You can write erase. Very similar to the router's configuration. Erase and confirm. And then you can do a reload and confirm. And you can press the space bar. And now it's going to ask you the question as if it's not being configured, which it shouldn't be. And now we can paste it in. All right. So interface VLAN 1, no shot. Okay, VLAN 2, DHCP, it took it. So the 10.10.10 is already up VLAN 1, so it should work. Let's take a look at it. So from here, we are going to on the desktop, and we can directly ping 10.10.10.10 directly and see if it works. And if it doesn't, then our next troubleshooting is, of course, ping the 10.10.10.1, the default gateway, and see if there's any issue of that. Okay. Let's give it some time and see if it will come up. Okay, so we need to add a few more parameters for it to respond to ICMP with ASA. It has to be a little bit more comprehensive. We give it a VLAN1, give it a name of inside. We have to tell them the security level is 100. And also IP address is the same as what we did before. And then VLAN2 is not important in this case, it's outside and security level is 0. And get a DHCP from the service provider. We don't even need those two DHCP line in there. The interface, they have total of 8 interfaces, 0 to 7. And usually on 0, make it to the outside. So it's VLAN2. And VLAN1 is the one that we connected to the 10.10.10. So we need to just recopy the whole, we can reboot it. Let's see. Go in here, and we're just going to say reload. And say don't save it, and confirm. And press the space bar, and of course, because it's not configured, so say no on that. And you can do enable, no password, and then show run, and you can see that, hey, it's not been configured. And you can see that, let's see, there isn't any IP addresses configured there. So what we will do is, then we're going to just use this updated configuration to copy it in. And let's hit paste. All right. And we're just going to tell them, hey, don't bring those line up. Okay. So once it's up, in here, we go to that again. And up arrow key, let's ping 10.10.10.10 this time. Now it's working. So let's just move it a little bit bigger so you can see it all in one line. Okay. Now we're going to see, we're going to add one. We're going to take this line off. So, of course, you can go to any line here, at any port. What we will do is we are going to add a sniffer. So go in here. Okay, so we are going to choose the sniffer here. And first, let us delete it. Choose this one. And let's delete this line, which is a sniffer. And we'll put it in here. Move it a little bit low. And we will choose a line to connect from this port to the sniffer. Connect it to the 0. And then from the 1, we're going to connect it to the port number 2. because the first port will make it VLAN 2. So any of those ports should work. Okay. So once we have it up, we just have to wait for it to turn green. And then we can actually, from the sniffer, and see how it goes. So you can see that VLAN 1 is up. Okay, so to troubleshoot, what we can do is we can actually, because the line, when we do that, in here, it's taking too long for it to come up. So if you choose the sniffer Ethernet 1 and you come in here, while you choose the right port, but you wait here, it will not come up. Waited for a while and it doesn't. You see that the port number, the port Ethernet 0/1 is not coming up. So to troubleshoot it, it will be using those magic number, the magic, I call it the magic one in here, and you can choose it and let it automatically choose it. It turns out to be that they want to use the crossover cable here, which I don't think in reality is needed. So we'll choose that. And you can see that once we choose the crossover, it started to come up. So we can wait for that. While it's waiting, we can actually go here and we can clear all of that. And there's nothing to configure about. So in the GUI, we just go ahead and see that. The filter already been all clear. So, but we have to see the ICMP, right? So we got to go IPv4 and we want to see ICMP packet. All right. Okay, so we just look at this. Okay, it's up now. So now what we're going to do is we're going to ping the arrow key. And now we go to the cipher. And I think it's already working on that. Quickly, we want to see that again. And you can see that the ICMP coming up. And let's take a look at it. And you can see that the source address is 10.10.10.1, and destination is 10.10.10.10. So it's actually using path. So 192.168.11.11, it goes out past the router, and it shoot it out. As a sniffer, it shows you that hey, it's already been translated out. And that's the syntax that we use anyways. Okay, if you put a sniffer down in here, if you put a sniffer down between the switch, when it goes out, you can capture the same thing without using the crossover cable. Okay, so anyways, that concludes this exercise, and we're going to move on to the next exercise. Inter-VLAN routing.